So here we have our setup of our redundant PLCs. As you can see, we have our bottom PLC currently acting as our primary. Now this will be a live demonstration of a switchover sequence for our PLCs. So the concept with this is I will be flicking the power off on the primary PLC, simulating a major fault. And as a result of that, through the active channel of the redundancy module, a communication will be sent for a switchover action, whereby the primary PLC will switch over with our synchronized secondary. You'll see the text PRIM occur on the top PLC, whilst disqualified or DISQ will be displayed on the bottom PLC if I was to restart the setup. So observing the text on the redundancy modules as I flick the power supply on. And you'll also note both of the channel lights indicating the activity of the fibre optic channels are now flashing red. That's another way of indicating that communication has been lost on both channels. As both are down, there is no current active channel. So if we was to restart up this PLC, well, the startup of the PLC is generally not something that you have, but that would be 3 minutes. To actually qualify, it can be as little as 30 seconds, so very fast. The idea is that it's going through its internal testing and verification just for the firmware itself, and then you'll get a sequence where it tries to identify its initial state, which will always be like a disqualified, whereas yet to verify that it can retake over control. You'll get a qualification sequence to occur where you'll have displayed on the redundancy module, and then once it's qualified, you'll see the sync text appear, and that's when you'll know you're good to go. And that's something that's also displayed in the RMCT as well. So as you'll see now, the original PLC is now in a disqualified state, symbolized by the text on the redundancy module. And now you'll see a process where it attempts to qualify, whereby it will detect the modules and the firmware revisions in the primary PLC. As a result, it will determine if it can then take control over that system, qualify itself, and then synchronize, and you'll get the text originally displaying when we started. And at that point, you'll have an active communication channel cross-loading, and the redundancy system will be ready to take over control in the event of a fault. So you'll now see the text change to qualifying. So that qualifying sequence is occurring, and after that has finished, you'll see synchronized be displayed on that module. And in this process, the only things that are occurring is it's testing all of the firmware in all of the modules, and it's testing that the modules are equivalent alongside the connections so that it can verify that it can take over control in that event. Now, an interesting point to make is the USB ports on these Ethernet modules. If you have a synchronized system and you were to plug in a USB cable to one of the ports on the secondary as it was being used, no disqualification would occur, but the issue would be as soon as you try to perform a switchover action, you would get the secondary PLC to become disqualified, and it would not actually take over control upon switching over, and there'd be no indication before that was going to occur. You'd only see it when you actually tried to switch it over. So that's something to avoid. If you were to try and, let's say, update the IP addresses through that USB port as it's being used, you must remove that cable when you're finished. Otherwise, it can cause a massive failure upon switchover. And even doing that while it's running can cause that event, so that's something to avoid. Everything should really be done through the Ethernet ports of the communication modules. Alive, yeah, so they've actually got a feature in the RMCT for that. So the idea is you perform a locking sequence. So in that locking sequence, the primary will remain the primary. However, the secondary will become locked rather than synced, and that will obviously remove the ability to have that redundancy when a failure did occur. But for that time, when it's locked, you can update the firmware, and after you've done that, also the program in and of itself, you can upload a new program into the secondary while that's occurring. And after you've done that, you can perform a locked switchover, and what that will do is it will switch over control, so the secondary will take over the control with that new program and new firmware, and as a result, an original primary will become disqualified. You can upload the firmware to that, and you don't need to upload the new program as that's already synchronized through the active communication channel. And once that's finished, you can resynchronize manually the PLCs, and that's the entire sequence. Is actually quite simple to re-upload the code and re-update the firmware as it's running. It's not something that you have to have a complete shutdown for. And, you know, obviously, as there are two PLCs, they've got a way to handle that changeover. The thing to note is, once you've got an online redundancy system, if you did need to downgrade the firmware version, that's not something that they allow you to do. It's only upgrading with new packages, and obviously there's no reason to reflash the same firmware to it. So that's the only way you can go is newer versions. Updating the IP address, yes, you would need to have a locked sequence where you would update it to the secondary and then perform that switchover, update it to the primary, and then resynchronize. But yeah, the important note is that when you do that, you do lose redundancy. So if a failure was to occur, there is no redundant setup to compensate for that. Yeah, the secondary locked, because what you'll be doing is originally uploading that to the secondary. As soon as you were to update the firmware, it would disqualify. But it's better to have, you know, the distinguishment in your event log, for example, that was something that was intended, as opposed to, you know, a communication fault or something like that. Obviously, you could upload to the secondary while it's running. All it will do is immediately disqualify and prevent the system from being redundant. But that locked sequence is a way to, you know, do that more reliably. You technically can, but it's not a good idea to do that. That's why they have that functionality present. Yeah, the good approach is to lock the secondary, download it to the secondary, perform that switchover, and then download any firmware that you need to the original primary PLC. Yeah, just the program. You only have to actually upload that to the secondary, and when you resynchronize that, you still have to perform that lock switchover. That's an important step. After you do that and resynchronize the PLCs together, that program is automatically loaded to the secondary from that primary. So that's not, you never have to upload programs to both PLCs. Yeah, so if you tried to download the program to the primary while it was running, it would perform, I believe it would perform a switchover, because that would be a failure. Obviously, it's losing control during that stage. An issue that may occur with that is if you had auto synchronization on, so as soon as it's got the new program there, and it would try to qualify, and then it would re-qualify, what you'd have is that PLC that you uploaded the program to became the secondary, and now you're resynchronizing it with the primary. That new program would actually get overwritten by the old program, because as I say, the program that's in the primary is cross-loaded to the secondary, and if the new program was on the secondary, you just lost that program. So it's not something that you can do during operation. You know, although in Studio 5000 you're connected to the primary in its run state, you can still view the status of the secondary and the primary through the RMCT, because that's separate for each module. Each module has their own RMCT, which is worth noting. So let's say if I change the synchronization option for auto synchronization of the primary to always while it's running, that will automatically be synchronized to the secondary, and then they'll try and resynchronize. So that's something to keep in mind. You don't have to go and do it for both if they are already running.